All right, let's jump right in. Today, we're going to break down a digital toolkit that is, and I mean this, absolutely essential for any engineering student who wants to actually build cool stuff and, make their mark.
So, here's the big question, right? As an engineer, you have these brilliant ideas popping into your head, but how do you actually turn one of them into a real-world product? I mean, that's the fundamental challenge, isn't it? Bridging that huge gap between a concept in your mind and something you can actually hold in your hand. Every single great designer has to figure out how to cross that bridge. So let's dive in.
Okay, so let's start by framing this. The engineer's core challenge. We're talking about taking a vision and making it tangible, functional, and, well, real.
The entire world of engineering really boils down to this one thing: transforming ideas into stuff that works. And that journey, from that little spark of an idea to a finished product, well, it's not magic. It takes a powerful, and I mean incredibly precise, digital tool to make it happen efficiently and, just as importantly, accurately.
So, what is this tool we keep talking about? Let's introduce it: your digital toolkit. This is what will bridge that gap between your imagination and the factory floor.
And here it is, SOLIDWORKS. Now, don't just think of this as another piece of software you have to learn. Seriously, think of it as your gateway to mastering 3D modeling. It's the digital sandbox where you can build, test, and perfect your craziest ideas before they ever cost a dime to produce in the real world.
What's really cool is how it breaks down the whole design process into 3 simple steps. First, you model the individual parts, the nuts, bolts, and brackets, getting every little detail just right. Then you build the assembly, which is like putting a digital puzzle together. You combine all those parts into a single system. And finally, you create the drawing. This is super important. It's the 2D blueprint, the universal language that tells a manufacturer exactly how to build your creation.
Okay, but why SOLIDWORKS specifically? There are other tools out there, right? Let's get into why this one is such a massive industry standard, why it's so trusted by the pros in some of the most demanding fields.
So, a few key things make it so popular. First, and this is a total game changer, is something called parametric design. Basically, it means your design is smart. Let's say you change the diameter of a bolt, well, the hole it fits into automatically updates to match. It's amazing. Then there's the fact that it has a tool for pretty much everything, from the first sketch to complex simulations. And maybe most importantly for you, it has huge industry relevance. We're talking automotive, aerospace, medical devices. They all use it. Plus, there's a ton of educational support and a massive online community, so you're never really on your own. Learning this isn't just for a grade, it's getting you ready for a real job.
Now, you've probably heard of AutoCAD, and a common question is, what's the difference? Well, it's actually pretty simple. Think of it like this. If you're designing a complex 3D thing, like a new car engine or a robotic arm, you're going to use SOLIDWORKS. But if you're creating a flat 2D floor plan for a house or a bridge layout, that's where AutoCAD shines. They're both super important tools. It's just about using the right one for the right job.
All right, now we get to the really cool part: moving from a simple design to a full-on digital prototype. This is where your creations truly come to life, long before a single piece of metal is ever cut.
I mean, just think about the power you have here. You can test your designs under real-world conditions without ever building a thing. You can find a weak spot in a design and fix it, or see how a new part will move and interact with others, all inside the computer. This saves an unbelievable amount of time, money, and headaches down the line.
And the kinds of things you can analyze are just incredible. You can run what's called an FEA, that's finite element analysis, to see exactly where a part might bend or break under stress. Or you can do CFD, computational fluid dynamics, to see how air or water flows over your design. Think about perfecting a drone propeller. You can even do motion studies to see how all the moving parts of your assembly will work together. And on top of all that, you can create these stunningly photorealistic images for presentations. I mean, it'll look like the product already exists.
Okay, so you're probably feeling inspired, right? Maybe a little overwhelmed? Don't be. Let's lay out a clear, actionable roadmap for starting your SOLIDWORKS journey.
So here's your path. First things first, get the software. And you're in luck, because most universities offer free educational licenses, so definitely check on that. Then, just start exploring tutorials. The software has built-in guides, and YouTube is your best friend here. Next, and this is a big one, join the community. Find forums, maybe a club at your school, learn from other people. And finally, when you feel ready, go for a certification. Something like the CSWA, the Certified SOLIDWORKS Associate, looks amazing on a resume and proves to employers that you actually know your stuff.
You know, this quote really nails it. SOLIDWORKS is more than just a CAD tool. It is a gateway to innovation, precision, and professional growth. And that's the truth. It's not about memorizing which button to click. It's about learning the language of modern design. It's really about unlocking your own potential to create these incredible, precise solutions to actual real-world problems.
So let's wrap this up. The takeaway here is pretty clear, right? You've got the fundamental challenge, turning your ideas into reality. You've got the tool that makes it happen. And you have a clear path to get started. The world really does need your ideas. So the only question left is, what are you going to build first?